Well, hello everybody and welcome back to Let's Practice on our first degree equations with one variable. This is practice number 2. So here we have an equation, an interesting one. Why? Because we have an external parentheses and we have an internal parentheses. So just remember, when you see that kind of equation, always open the internal parentheses first and then open the external parentheses. So let's see how it works. Even here I wrote down the shorthand equation to how to open a parenthesis. A times B plus A times C. So we're opening the internal parentheses to get this term right here. Minus 5x times 3x equal to minus 15x, and minus 5 times minus 1 equal to plus 5. Now let's open the second parenthesis by multiplying 3 by this term, and 3 by this term, and 3 by this term, and we get what we have right there. Now we need to move terms around in order to get all the x's on the left and all the thing without the x on the right. And we did it. Now let's add the terms and divide by the factor minus 20, and we get that our answer is x equal to 3 divided by 2. Want to do another one? Let's do it. Right here in front of us we have an equation that have a double set of internal and external parentheses. That doesn't make a difference. We're just going to do the same as we did before. We're going to open the internal parentheses first, and we're going to get what we have right here. And then let's open the external parentheses to get what we got right there. Now let's move the terms x's to the right and think without x's to the left. No, x's to the left and terms without any x to the right, and we get this. Let's add the terms and we get 4x is equal to 40. Now, as you guessed it, yes, we're going to divide both sides of the equation by 4, and we get that x is equal to 10. Okay, started getting easy, right? It's not that hard. Good. So let's do another one. All right. So what do we have here? We have fractions. Okay, now we have our equation, and we see it as the addition of fractions. Okay, that's not a problem. Let's just introduce an additional tool that I call flatten the fraction, meaning that let's take this presentation and make it like one line, one flat line like we had before. So let's consider this. Let's say we have one fraction right here and another fraction like that, and I want to sum it up. Okay, what I can do is to transform this expression into this expression. Well, I just multiplied the red one by 1 and the blue one by 1. Actually, I didn't do anything, and that was the whole intention. I don't want to change the value of what I see. I want to only change the presentation. Now, why did I decided to multiply by 1? Because every number divided by itself is 1. So I can choose this 1 to be any number divided by itself. I can choose any number also here. So let's see what I chose. Right here I chose to multiply it by d over d. Why? Because d is the denominator on the second equation, on the second fraction, sorry. And here I decided to multiply it by b over b. Why? Because b here is the denominator on the first fraction. And what does it give me? As you can see, now I have two fractions, and these fractions have the same denominator, a common denominator. And by the rules of adding fractions, I know that if they have a common denominator, I can add them up, just like so. So we can transform two different fractions into one fraction. So let's take this tool, put it on the side, and use it to solve this equation. Okay, so I have 15 divided by 15, which is 1, multiply by the fraction that I had, 3x over 2 divided by 6. And right here I have a 6 divided by 6, which is 1, multiplied by 4x minus 2 over 15, which is what I had before. Now I have the same denominator on both, and I can add them up. Now I have only one fraction to deal with. Let's multiply both sides of the equation by the denominator, and I get that this multiplication cancel out the denominator and denominator right here, and I get this expression right here, which is flattened. That's why I call it flattened fraction, even though it's not a technical term, but you know what I mean. Now let's open the parentheses, and we get this term. Let's move the terms, and let's they're already good. I removed them on the same step. I moved them. I moved the 90 to the left and the 12 to the right and the 30 to the right, and I add them on the same step. This way is look like a jump. Now let's divide by the x factor to get x equal to minus 2. Okay, don't worry, going to do another one with a fraction, okay, because this new concept right here need practice. So let's go to the next one.